Okay, the next guy, so open or close at -4. Close and 6 will be open. All right, so here we go. If you read this, cover the other one. How do we read that? X is less than or equal to -4. If it's less than -4, what direction? To the left. Good. Okay, now the other one is X is greater than 6. To the right. So that's opposite direction. So in this case, it means it's everything but the numbers in between and not including 6. Okay, so very two scenarios. So you need to be able to actually write notation this way today. This one, number 4, if I wanted to write the other notation, it would be a round bracket. So it's between -5, comma, all the way to 4, and 4 is a closed bracket, is the other notation. So this is called interval, this one here. And set builder notation. Okay. Now this last one is a little different. If we're not going to cover how to write the last one, 5, in the set builder. But if I wanted to write 3 that way, yeah, let's do it. 3 would be from -1, would that be open or closed? It'd be a closed bracket, comma, all the way till when? Infinity. Now infinity always has a round bracket, because infinity is not actually a number. Infinity is numbers getting larger. So a common misconception is we think about infinity as actually a number. It's not. It's just numbers getting larger. It represents or getting smaller. So the number 2, how would you write it in set builder? We go left to right. So it actually starts at -infinity, which is a round bracket, all the way to 4, and is that a round or a square bracket? It's rounded because it's what we call an open bracket. It's because it's not equal to 4. That's why infinity is a round bracket, because it's not actually a number. It's not actually right? It's just numbers getting larger. Okay, so let's try these. I want you just to try an interval notation just with the inequalities. Okay? I want you to try to write the inequalities. Now here's a hint. When it's either between two numbers or fanning out opposite directions, our variable goes in the middle, the smaller number goes on the left, and the larger goes on the right. And then you need to fill in your inequalities. So do one at a time. Cover up this one, fill in the inequalities for x and -6. Cover up this one, fill in the inequality for 4. So x in the middle, smaller number on the left, larger on the right. Try all of them. messed up the names. I knew it. I knew I did. I messed up their names. That's set builder, that's interval. I don't know why I would do that. Okay. Switch arrows. So set builder is the inequalities, and interval is for the brackets. Okay, how did the first one go? Okay. So, x is it greater than or less than negative 6? Should be greater than or equal to. Oops. And x is less than or equal to 4. Okay. How would you write the next one? You'd write negative 3 and then 8, x in the center. So you'd write x is greater than negative 3, less than or equal to 8. So notice if it's in between two numbers, it points to the left. Okay, we'd write negative 3x and then 1. X is less than negative 3, greater than or equal to 1. So they both point to the right. The last one would be open at negative 2, closed at 5, and shaded in between. Open at 0, closed at 6, shaded the opposite directions. Okay. Is this review for you guys for the most part? Okay. So let's actually get to some domain and range. I need a pen. So let's turn the page. We're good to go? Get to some new stuff? Makes sense, it's set builders, the inequalities, because we're going to write it actually as a set. I don't know why I messed that up. Okay, domain and range. So here is, I don't know if you have a highlighter, but this is really important. Domain and range, where it describes the location of the graph. It does not tell you the shape or the rate of change in values. All it tells you is location. Okay, where does the graph located? Domain describes all the x values. And the range describes where all the y values are. So, here's an example of discrete data. Okay. So, we're going to do interval notation and set notation. So first, let's do, no, we're just going to do, in this case, only interval, or only set. Oops. So, hola. I hate when that happens. Okay, so set notation. And it's going to be really weird, and this is why we're going to spend 2 days on this. Okay, so the location of the x values is all the x coordinates. So location domain is where all the x values. So what are all the x values? Starting at the lowest one. Negative 3, comma, negative 2, what else? Negative 1. Now, are we going to write negative 1 twice? No, we're going to only write it once. Even though there's 2 points at negative 1, we're only writing it once because it's just location of our graph. Then comma, 0, comma, 1, comma, 2. So this is the domain. It's the location of our x values. This is our domain. The range is the location of our y. It's the range. This is domain. I'll write it above. Okay, so where is the y values? What y values is our graph located at? Start at the lowest, negative 2, then 0, then 2, and 3, and 4. Okay, so discrete, we're just listing the actual y values or x values, depending on domain or range. Okay, so here, let's talk about the next graph. And we're talking about the domain is the location of the x's. How far left and right? Okay, you can ask yourself with domain, how far left and right? Whereas range would be how far, what? Up and down does the graph go. So we're only talking for the x's, is horizontal, range is the vertical location. How far left and right, how far up and down. Okay, B, how far left does the graph go? And I used to use a highlighter to show this. If it made a shadow onto the x-axis, where would it land? -2 all the way to 1, right? How far left, I should make this a lot larger. Sorry, guys. View, zoom, try 200. Okay, we're asking how far left does the graph go. It goes all the way. The farthest left x value is -2. The farthest right x value is 1. So how would we write that? Put x in the middle. Okay, the smaller number on the left, which is -2, larger on the right, which is 1. Then we fill in our inequalities. Now when it's in between, they both point what direction? Well, let's think. X is it greater than -2 or less than -2? Greater than or equal to, and then x is less than or equal to 1. Okay, so how do we write the domain? I'm going to show you the set notation. We're going to actually write it as a set. So this is the formal notation. We write set brackets. We're talking about which variable? X, so we're going to write X with a bar. So we're saying, hey, this is the information about X. This is the location of our X's. Our X's is between -2 and 1, comma. In between, is it continuous? Yeah. And so in between those two values, we'd write comma X is an element of the real numbers. Okay, this is our set notation. Weird looking? No. Minimum, you only have to actually write this part right there. Okay? But you need to get used to both. The proper and formal notation, and then the improper. Okay, so how do you think we'll write the y's? So, set brackets, y, and a bar. So we're talking about the range, y. So now when we ask ourselves how far up and down, how low does the graph go? What's the lowest y value? -4, right, y in the middle. What's the highest y value? 4. Once you get used to this, which way do the arrows point? To the left, to the left. Right, when it's in between two values, if you write it in the proper order, lowest to the left, the highest on the right, it'll always point to the left, comma. Is it continuous? So in between those points? Yes, y is an element of real numbers. Yes. No, I'm pointing left. If it was an arrow, think of it as an arrow. Okay. Do my arrows not look very arrowy? Okay. So this is now, if I told you interval notation. Super easy. Okay? The domain would be what? Between what two x values? It was -2 and 1, and would it be open or closed brackets? It's closed because it's a closed circle, right? It's not an open circle. Range, -4 to 4, and again, open or closed? Closed. Unfortunately, for you guys, math 10, 20, 30, we mainly use set notation. If you take calculus and the AP exam, they interchange between interval and set. Sometimes they use interval, sometimes they use set. More often than not, they actually use Yeah, way more. So we're going to actually, we do this a lot more, grades 10, 11, 12, until it's second nature. Because that is so easy. Why don't we just always use that? Right? I guess the reason why is we could say, we could do like y is an element of integers, and so then it would just be the dot, just the actual discrete point, which we'll get into later. I don't know. Just interval is so much easier. But, so bare minimum, what I need to see is that part right there. Okay, but you'll usually see the whole set. All right, let's talk about the next guy. Domain. How far left will this graph go? Does it have arrows? Careful, these are arrows. I know, and it might be hard to read. And realistically, this is not a good graph. Because a good graph actually will just keep touching to the end of the graph. Instead of using arrows, I can't trust. Let's use this. Yeah, exactly. Okay, a good graph should actually just extend to the end of the actual graph. And that will tell you that it keeps going forever and ever to the left and to the right and up and down. So, do you want to take a guess on how you would write if it keeps going to the left forever and to the right forever? Infinity to infinity. Well, you just told me interval notation, which is negative infinity to infinity. Numbers keep getting larger and numbers keep getting smaller, depending on which direction you're moving. Now, how do we write that in set builder notation? X is an element of all real numbers. Okay, XER. So in set builder notation, X is an element of the real. So we don't need to. We just say it's all real. It's all numbers in set notation. So this would be an interval. We would write the negative infinity to infinity. We never use the infinity symbol in set builder notation. Okay, we only use to say X is all real numbers. That's basically saying the exact same thing as this, just a different notation. So what would we say for Y then? Same thing. Y is an element of, because it goes forever up and down, it's an element of the real numbers. How would you write the range? Negative infinity to infinity. Remember, infinity is always an open bracket because it doesn't actually end. Right? A closed bracket implies an actual ending. An actual point it ends. Numbers getting bigger doesn't actually have an ending. Okay, turn the page. A long lesson, eh? Sorry I spent 2 days on this. We're going to just try and get through. We'll see, this might go faster now. Okay, X, how far to the left does this graph go? Careful, it has arrows, so it should extend. Whoop, whoop. There you go. Okay, how far left will it go? Negative infinity, so forever to the left. How far right? 0. So how would we write that if it's always below 0? X is, yeah, it's always a negative number and 0. So how would you write that as an inequality? Less than or equal to 0. That's it. Comma, XER. So within that, X is less than 0. Those are real numbers. It's continuous, we're saying. Range, how far up? Infinity, how far down? Negative infinity, how do we say that then in set notation? If it's all numbers, forever up and forever down. Y is an element of the real numbers. Okay, so there's set notation. Interval, how would we write interval? From negative infinity to 0. Oops, open or close at 0. Closed. It actually ends at the particular point of 0. And range would be negative infinity to infinity. Okay, I'm going to focus from now on set notation. Do you want to try the next one by yourself or together still? Together, okay, x. How far left is this? Where is the location of the x values, this graph? Negative 2 till when? Infinity. So how would we write that? Like think of it this way. If a shadow is casted on the x-axis, it would start at negative 2 and would it keep going forever? So how would you write that for the number line? X is greater than or equal to negative 2, comma, XER. Range. You cast a shadow, for how far up will this graph go? How far down? Will it keep going up? Like if we extend on until larger and larger numbers, will it keep going up? Yes. Will it keep going down? Yes. So how do we write that? YER. If it can be all values, y is an element of the real numbers. How you feeling? Does your head hurt? It'll get easier, I promise. It's, learning new notation is like takes practice. Okay, I want you to try this next one on your own. Right, your domain. So domain is x, range is y. Your domain and then write your range. So what's my location of my x coordinates? Forever left and right. And then what's my location of my y? Is it forever up and down? Does it have a starting point? Do the x's have a starting, like, does it go forever left and right? Yeah. So what would you write for your x? X is an element of the real. It's negative infinity to positive infinity. So x is an element of the reals. Range, yeah? Yeah. A graph where it's not a part of the real numbers? Yes. We can do an example after. For sure. If it's continuous, right, we can draw it without lifting our pencil. It's always real. It's element of the reals. Right? Continuous. It could be any decimal in between, right? Okay, y, how far up and down? Is there a starting point? Yeah, it starts where for y? Vertically. At 3 and then it continues to infinity. So how would you write that? Y is greater than or equal to 3, comma, y is an element of the reals. Thank you. Negative. Whew, that was a close call. Stressing me out here. Okay, do you want to try this one on your own?
No.
How far? Let's try it. Give it a shot. So domain is your x. If you forget which one, domain, range, you could think of it as like Dr. XY or alphabetically DRXY. I don't know. Domain is x, range is y. I don't know. Just trying to help here. So this time it's between two numbers, right? So you put x in the middle, y, oops, range is y. X in the middle, your two numbers, and then put in your inequalities. draw a perfect circle. Almost impossible, I'd say. There's competitions every year. And like actually I'm drawing perfect circles. Dead serious. Yes. The only thing I would say for make sure you go comma, XER, comma, YER for as far as your notation goes. But it looks like most of you got this. Your x, the farthest x value is -5, and the farthest to the right is +5. And it's in between. So x is greater than or equal to -5, less than or equal to 5, comma, x is element of the reals. Again, this is the part that really matters, that I want to see. Y values, the lowest y value, -3, highest is 7. Greater than or equal to -3, less than or equal to 7, comma, y is an element of the reals. Okay, good. So let's turn the next page. And let's look at I. Okay, I'm going to show you two ways that you could write I. Two different options. So we could actually just write it the elements of the set. For domain, okay, what are the values of our x? -2, what else? -1, 0, 1, and 2, okay? The other way I could write this, or we could actually write this as, this is very, you have to be very careful with this. Like I would almost say write it as discrete points, discrete data. I would stick to this. But for the sake of an example, you could also write this as x is greater than or equal to -2, less than or equal to 2, comma, x is an element of what numbers? Close? Integer. You could also write it that way because it's all the integers between -2 and 2. Right? It includes all the integers between -2 and 2. And integers don't include decimals or fractions. It's only those discrete points. So both of these are okay for your domain. Range. So what's one, like just writing the points? What would they be? Range is y. How far up and down? 0, 1, and 2. Or is it all the points 0, 1, and 2? Yeah, 0 to 2. You could write this as y is greater than or equal to 0, less than or equal to 2, comma, what type of numbers are 0, 1, and 2? You could actually say integer. You could say integer. You could also say what? Whole numbers. Y is an element of the whole number. So that's the other way. So that's an example, right? When it's not continuous, when it's not XER or YER. Now, is it easier just to write this way? Yeah, it's so much easier. So why not just do that? Okay. Let's do this. Well, I want to skip it. Okay, let's just do this one quickly. Using the values provided, give the domain. What would be the domain? Okay, which one is the x variable?
Years.
Year. The first is x, the second is y. So years is actually on the x-axis. It's going to be our domain. Okay? And what are the values? Now, if we're talking about year and number of vehicles, number of registered vehicles, if we're given a list of data, we could just list those points. So our domain would be 1916. Oops. Don't ask why I put a comma in there. 1956, 1975, 1997, 2008. What's our range? I'll let you write that. All those numbers. Woohoo! It's It's a lot of zeros to write this morning. Does it ever make you crave donuts? Now I did. Power of suggestion. Okay, we're not going to graph this though, but let's just state the independent variable. Which one would be independent? The domain or specifically what's the variable? No, what do we call the variable? Yeah, we call it years. The year. What's the dependent? Number of vehicles. Does it make sense that the number of vehicles depends on the year? Yeah, it doesn't make sense that the year would depend on the number of vehicles. The number of vehicles depends on the year that we're looking at. Okay, so that's why number of vehicles is our dependent variable. Time is almost always, just be very careful what I say, almost always independent. Okay, time is, you learned that in science, right? You always put your time on the x-axis. It's the independent variable. Okay, so let's leave it at that. What I'd like you to do, I have provided you with a whole bunch of extra practice. Okay, now I think you could start your homework for today. So there's 2 assignments for this unit. So we're going to do some of these extra practice stuff in tomorrow's class. Okay? So for today's class, and then you're going to have a handout for homework. So for today's class, I'd like you to get started on page 426, numbers 1, 2A through D, 3A, B, C, F, and 4 to 6. What I will say is, yeah, that's good. What? That's yesterday? Let me see. No, you did 416. Oh, sorry. You're right. The page number's right. The numbers are wrong. Let's try this again. 426, 1, 2, 3, AC, 5, 6, and 8 through 10. Now, what I will say about, should be okay. Yeah, you'll be good. You're going to be good. Okay. 426. Tomorrow's class, I'm going to go through more of these, like this handout. We'll do a little activity I have, and then you have a worksheet for homework. Okay? And if it's kind of hard at first, it'll get easier, I promise. If you practice. Okay.
Wagner, here are your announcements for Tuesday, November 17th. A reminder that Tea Club meets each Wednesday at lunch in room 238. Bring your lunch and a $1 donation. There'll be a wide variety of treat teas to try. The GSA is meeting today at lunch. It'll be held in the art room 037 instead of our usual meeting spot. There'll be a media club meeting in room 030 today after school. New members are always welcome. There's a junior men's basketball tryout on Wednesday morning in the West Gym at 7:15 a.m. And there'll be a junior women's basketball tryout on Thursday morning in the East Gym at 7:15 a.m. Would all interested players see Mr. Bedemus today after period 2 dismissal. Today's wrestling practice has a special guest coach, Mr. Gord Birdie. He's represented Canada at the 76 Olympics, the Pan Am Games, and the Commonwealth Games, World Championships, and World Masters Championships. Please do your best to make sure you attend. This is a great benefit as we get ready for our first tournament on Saturday at the U of A. Also, if you need to get forms to pay fees, please make sure this is done as soon as possible. Forms to Ms. Hoffmeyer in room 239 and money to the office. If you can't pay all the money at once, please sort out your payment plan with Mrs. Rose. Intramurals, today is the big day. Come down to the East Gym and check out the dodgeball action. On Court 1, we have BWA versus the Ames game. And on Court 2, we have the Band Geeks versus Dodge is Life. If you signed up as a rep, please be in the East Gym right after the bell. Also, your SU will be selling Wagner's flag and STC cards for $10 at the door, so come and check out the excitement. There's no symphonic band rehearsal today after school, but the band will rehearse on Thursday, November 19th at lunch. And all members of the Wagner Music Festival setup crew are reminded that you work today after school from 3:30 to 5:30. Please meet in the band room. Are you looking for a job? A representative from McDonald's Restaurant will be here in the Cap Mall on Thursday, November 19th. That's all the announcements for today. Everyone have a great day. Taylor Callan, Samantha Biasini, Justin Bell, Austin Connell, Owen Jackson, Kristen Yolanda, Damian Wick, and Jocelyn Evans. Please come to the main office.
What is all this? Thanks for that. No, these are real. Oh yeah, that's I just took out the bag. Then I took the book out. I'm as soon as I'm dead. I'm thinking strong. It's worth trying. Running away. Use it. Oh yeah, you got the game. Everything you got. Thanks, most of the book. $4. Yeah, I'm pretty sure the book's $4. Oh yeah. I got his arm.
Alright guys, let's go. Hi everyone. Oh no, grab this. Grab that. Sorry. Grade 10s.
Right there. So it's okay for you to not get it, but everybody else. I mean, it's okay for you.
You know what? We're going to do it after we get through our stuff. Our exam's on Thursday, right? It doesn't matter. We have stuff to do. I'll look it up later. Okay. Can we go to where we left off, which is that last page of your notes package? Okay. So yesterday we talked about transformations of radicals a little bit, and we're going to talk about solving radical equations today. How do we solve them? So we're going to really quickly go through how do we graphically solve radical equations, and then how do we algebraically solve. All right. So graphically, we have two methods. Record. Uh-oh. Darn it.